Someday you are going to die. Sorry, that was a little cold to start. Let me rephrase that real quick. Someday you probably will die. For the existence of humanity, we have strived to stop the inevitable. Our zeal for control has shaped our society in ways our universe has never seen before. Yet, at the end of life, we are no different than anything else. Death is all around us. We see it everywhere. It is the second most universal theme in our existence. It is no surprise that for centuries we as humans have been searching for the cure to our biggest fear, yet every generation before us has failed to find it. Failed to find the secrets of our inevitable death, and maybe not make it inevitable. Approximately 107 billion people have failed and fallen victim. What good of a shot do we have? Well, our generation has one of the best chances of life extension we have ever seen before. Many of us look around and believe that we are on the brink of extinction, but they fail to realize that we are also on the brink of extension. But that begs the question, how do you stop the inevitable? Everybody has heard of this as a solution to extension of life, partly because the media, through TV shows and movies, have used cryopreservation as a successful way to get someone from the past into the future, hurtling over the years and running from inevitability. However, it is not as easy as our forms of entertainment have portrayed. For starters, you already have to be dead to be successfully cryopreserved. The theory for most scientists working in this field is that they freeze someone classified as dead, although they don't consider them as dead, and they hope to have the technology in the future to resurrect them back. It's a big gamble, but if you are already dying, why not freeze your dead body and maybe be revived later in the future? What do you have to lose? The problem with this relies heavily on the moral and ethics behind the practice. The theory is already being attacked for unethical practices because for some reason you can't freeze a living human, and even a deceased person is pushing the ethical boundaries. But even if they were to figure out how to successfully revive someone, how likely is it that scientists have discovered cures for every disease and seemingly reverse aging? It would be a big investment for your loved ones paying for you to remain cryopreserved in the hope of something that has only been talked about in fiction. Especially right now in this field, we cannot even freeze and revive individual organs, let alone any mammal. Additionally, if you were thawed out many years later, who would you know? Your entire generation had been long gone and forgotten. Sure, you would be living, but would you really experience the joy of being alive? Even if you were able to freeze yourself and wait for life extension, would you really want to? Okay, so maybe freezing yourself isn't the right option, but what is stopping us from manipulating time with gravity? Anybody that has seen the movie Interstellar knows that time isn't constant. It can be manipulated, either slowed down or sped up. If you have not seen the movie, there is one scene where the characters find themselves on a planet near a black hole. The gravitational pull was so strong that it manipulated time, so an hour spent on the planet was 7 years back on the docked spaceship. When I first watched it, my mind was blown. Comparing the ages of the characters who spent time on the planet versus those who didn't was crazy, since those on the planet appeared to only age an hour's length. With the amount of accurate science used in the film, why couldn't aging be solved through a gravitational pull like the manipulation seen in the movie? Well, the answer is a little bit more complicated. In theory, yes, gravitational pull does manipulate time, which is really hard to grasp since all of our lives we are thinking that time is a constant. It is not. Visually, it is seen here. Light traveling from point A to B with no gravitational pull is going to get there faster than light traveling with gravitational pull. This is the premise of space-time and how it can be curved by gravity. GPS satellites have to account for this as their internal clocks run faster than ours on Earth to stay consistent. So, does this mean to solve aging we have to increase our gravitational pull, or move near a black hole, where time is seemingly frozen? Even if that was possible right now, it would unfortunately not solve aging as effectively as it would seem. This is because no matter how fast or slow the clock hands turn, you wouldn't feel like anything has changed. Time is relative. Your new time zone would feel normal and you would live however long you were going to live normally. Well, if that doesn't work, what if instead of living by a black hole, we were flown in a rocket at light speed? Surely that would slow down our aging because of Einstein's theory of relativity. Nope, still relative. Your time in the rocket would still feel the same as your time traveling on Earth, even if every second passed on the rocket was 1,000 years on Earth. Plus, if you were to successfully do this and come back to Earth, you wouldn't have experienced those thousands and thousands of years. Instead, it would be similar to the cryopreservation where you jump forward in time. A good idea in theory, and technically you do live longer, but you don't experience living any longer than you would normally. Instead of blasting ourselves out into the cosmos to try and solve aging, why don't we try looking more inwardly to find the answer? Now, for as much as we know about the human body, we still don't have a strong understanding of why we age. It is a fundamental aspect of every living thing we have ever experienced throughout our existence, yet we still don't exactly know what is causing it. Why do we age is just one of those questions that for a while people just answered with a shrug and said, just because that's what happens. Now, more than ever, we have countless scientists searching for the reasoning behind life's end. If we figure out the why, maybe we can figure out a way to solve the problem. Right now, we are trying to solve the puzzle with all the pieces upside down while being blindfolded. But the strides that scientists have been making within the past few years are quite remarkable, and could help us potentially solve this puzzle. This is Cynthia Kenyon, a researcher from UCSF and currently at a private company named Calico, and she likes playing with worms. Well, more specifically these little guys called C. elegans. They are about the size of a comma on a page, and they are used as guinea pigs for a lot of aging research. What Kenyon discovered is that in C. elegans, there is a mutation that can occur in their genes which can double their lifespans, practically slowing their aging process completely. These mutated C. elegans lack the DAF2 gene, which governs the metabolism of the creature. Basically, without the DAF2 gene binding to the cell, there is a specific gene named FOXO which is allowed to enter the nucleus and turn on specific genes that support longevity. If this idea was implemented in humans and has the same effects as those found in the worm studies, 60 would be the new 120. This could be one of the major keys to solving the age epidemic, by slowing down our body's processes and promoting certain longevity genes. It seems a little too good to be true though, doesn't it? Well, that's because it is. If it was already solved, you would have heard of it by now, and not on some random YouTube video. One of the new challenges that scientists are facing now is finding a way to prevent the human equivalent DAF2 gene from binding to our cells. We need a DAF2 killer or a FOXO activator in order to see the results that the C. elegans had in their trials. But you can't entirely kill the DAF2 gene because it is a vital gene for cell growth and development. Now, the scientists behind this research are very quiet about their findings, and it is difficult to predict when an age-related drug would come onto the market with these findings behind it. But if it ends up being a bust like a lot of other experiments and potential miracle drugs, there is another scientific theory to aging which might be even more favorable. Let me take you back to high school biology real quick. Trust me, it will be fine. You remember those things called chromosomes? You know, the X little thingies that you would have to draw 100 times to visually show the stages of mitosis? Yeah, well, those are made up by your DNA, and they make you, you. At the end of those chromosomes are a little bundle of extra code called telomeres. They are basically a little pack of similar code just in case the chromosome is missing some vital code throughout its formation. These little ends are vital to cell formation and cell health. However, each time the cell divides, a little bit of the telomere gets shaved off and eventually the telomere will run out. This is essentially the Hayflick limit. Time is not the problem for aging. It is the amount of times that the cell divides in your body that is the root of the problem. The shortening of telomeres limits the functionality of stem cells, slowing down regeneration in the body, and worsens organ maintenance during aging. It also advocates for replicative senescence, basically zombie cells that are not living or dead, and apoptosis, the death of cells. Luckily though, there is an enzyme called telomerase in the body, which basically repairs the telomeres to become optimal once again. But, like everything, telomerase over time will degrade and not be as effective, making the telomere shorten to the point of death. In 2010, there was a study conducted on mice. These mice were genetically encoded to be born without this telomerase enzyme. They aged prematurely, but then scientists activated telomerase production back into the mice, and surprisingly, the mice became healthy and got younger as time moved forward. Some of these mice had osteoporosis, neurodegeneration, organ failure, and were non-fertile. But after the activation of telomerase production, the mice became strong, fertile, and fully replenished from its once degenerated state. If this idea was brought to humans, telomerase reactivation in cells that have stopped working could potentially reverse aging and keep people healthier for longer. But once again, if it isn't big on the news, and you only have heard of it from a random YouTube video, there must be some downsides to it. There is skepticism with reactivating more telomerase in our bodies. One of the main reasons is the correlation between too much telomerase and the increased chances in developing tumors and cancers. If there's more cells that can keep themselves alive longer, there's a higher chance of an overbuild that would be uncontrollable. That's also known as cancer. More does not always equal better. You know, slowing down aging and eventual immortality is just something of fiction and futuristic hopefulness. It's not like there are things we can do right now to keep ourselves functioning optimally and increase our health span of our lives. Exercise, eating right, adequate sleep, no, those don't work. It's not like there are biological differences that can be made in your body if you started eating nuts and vegetables instead of chemically modified empty caloric foods. That would be silly. We should just wait for these scientific research ventures to make a miracle pill that would disregard all of our healthy life choices. Let's just wait to upload our consciousness into computers. Forget this fleshy vessel that is weak and fragile and can break down easily. Surely we can expect to see a computer that can process all the unique 86 billion neurons that we have in our brain. That's not to mention all the trillions of molecules we have in the brain that is similar to a powerful computer that would need to be individually coded for interactions and simulation. Yeah, I think I'll wait for that instead of eating a fucking apple. Aging is sort of beautiful when you think about it. Like everything, life is a cycle that is forever occurring. Throughout the course of this video, multiple people have left this earth, while others are just taking their first breaths. Aging is inevitable. It is something that will happen with life. But that also means that life is inevitable. Even if it's not you that will be able to live forever, there are those behind you that will carry the torch into the unknown darkness of the questions we face today. We spend our entire lives worrying about the inevitable, worrying about getting lost time back, worrying about things that will not matter. when you are on death's doorstep. Focus on making the lifelong memories that have not been made yet. Focus on love, learning, laughter. Focus on the things that make you the happiest in your life. Because if you work on your passion, or laugh with others, or love the ones around you, you will not need extra days on this planet. It does not matter if you are old or young. We all have ample amounts of time left on this planet to make a fulfilling life. You just have to go out and find it.